Greetings, alert physics students, and welcome to the first video of Physics 102. Video 1-2. You'll wonder what 1-2 stands for? Well, all through the semester, videos will be labeled by the sections from the book from which they're drawn. So first thing we're going to cover is section 1-2. And so the videos will go up. The next one might be, say, looks like it's 1-4, then 1-7. We're not going to hit every single section in every single chapter. But we are going to hit chapter 1, and we're going to go straight to section 2. And section 2 is all about dimensions and units. They are not the same thing. Okay? Now, when you hear dimensions, you might think, X, Y, Z, whatever. 3 dimensions, 3 spatial dimensions. There's another use of the word dimension in physics, and we're going to look at it. So what we've got here is I'm going to make a list of 3 dimensions that are going to be important for us. I'm going to make a table. It's going to cover most of the board here. Okay, there are going to be 3 dimensions that are of great importance to us this semester. Next semester there might be a couple of others, but we have 3 dimensions. Again, not X, Y, Z. We're not talking about space here. We're talking about the word dimension in a brand new way. So the first one is length, and it's symbolized by capital L. The dimension of length is symbolized by capital L. Not all lengths. Sometimes we might call it length X, sometimes you might call it D, but length, the dimension length, is symbolized by capital L. Mass, we don't even know what mass is yet. We're going to talk about mass plenty later on, but just know that there is a dimension called mass, and it, surprisingly, is notated by capital M. And finally, the dimension of time, which is capital T. Those are our dimensions. Okay? And of course, when we talk about physics, we're talking about measuring things. We want to know how far it is between 2 cities, or the length of a rod. We want to know how much mass there is in the sun, or we want to know how much mass there is in an electron, or how much mass a car has. And time, of course, we're all familiar with time. So when we measure the physical universe, we have to measure these different dimensions of it. And the only 3 that we deal with this semester are length, mass, and time. That's it. And notably, combinations of those. Those will come up, and I'll mention those in a few minutes. Maybe this video, maybe the next one. We'll see. So, dimensions are length, mass, and time. Now, that's dimensions. Then there are units. So everything over here is a dimension. Everything over here will be a unit. So we have different units, right? We have English units, which we in the United States are used to using for the most part. Not always, but for the most part, we use English units. Things like the mile, things like the foot, things like the pound. Those are all English units. We can measure length in any way we want to, right? We can measure the length of a football field in yards, or we can measure it in meters, or we can measure it in feet. We can measure it in any unit. In the English system, the unit of length that is used to the unit that is used to measure length is the foot. And we're all familiar with that. In the English system, the unit used to measure time is the second, and we're all familiar with that. Other units of time exist, right? There's the year. Okay, there's the nanosecond. There's something called the galactic year. Okay, there's all kinds of measurements of time we could use. We, in the English system, use seconds. Now, the unit of mass, we never use it. There is an English unit of mass that you never see used anywhere in America, or for that matter, any other country that I know of in the whole cosmos. I'm not making this up, just so you know. The English unit of mass is called the slug. Okay? So those are our standard English units, which we do not use in this class. Okay, those are just the ones that are, the foot and second are familiar, the slug is not, but those is in a system of units called the English units. And foot measures length, slug measures mass, second measures time. Then there is our unit known as the SI units, which we will be using in this class, in Physics 102. Okay. SI, International System of Units, it's metric. Okay. It's metric. And the standard unit of length for us in the class is going to be the meter. And the symbol for the meter, lowercase m. Okay, that's how meter is notated. The standard unit of mass in our system, in our book for this class, is the kilogram. Symbolized, notated, small k, small g. And the standard metric SI unit of time is the same as the English unit of time, which is the second. Sometimes the SI system of units is known as the MKS system of units. Okay, I got to look through here now because I'm getting squeezed out over there on the right side of the board. So these are the units we'll be using. Oh, second is notated with lowercase s. Okay. So these are the units we use. Notice that both meter and foot measures length. Both kilograms and slugs are measures of mass, are units of mass. Both seconds, and seconds are the same thing, are units of time. But I could have picked for length, we can pick any unit of length. There's the angstrom, right? There's the light year. There's the furlong. There's all kinds of standards of length that we could pick, but the one we're using in class is the meter. There's all kinds of standards for mass we could use as well. We could use the atomic mass unit. We could use the solar mass unit. We could use the metric ton. We could use whatever we want to, but in this class we're going to use the kilogram and not the slug. We could also use any unit of time we wanted to. And all units of time describe the dimension of time. All units of mass describe the dimension of mass. All units of length measure the dimension of length. All right, for second, there are, again, an infinite number of units we could pick. I mean, for time, like I said, the fortnight, right? We could pick the fortnight and do all of our math all semester long, all year long, in terms of furlongs and metric tons and fortnights. We could pick any combination of units we want, and we could do all our math in it, but why make it confusing? We're using meter, kilogram, and seconds. Those are our units. And I do want to make one comment about the kilogram. Kilo, right, is a prefix in the metric system. It means 1,000. So a kilogram is 1,000 grams, right? So 2 kilograms is 2,000 grams, right? And 2 kilo mockingbirds is 2,000 mockingbirds. You get it. Okay, so this is also can be written as 10 to the third. 1 with 3 zeros after it is the same thing as 10 to the third. We'll be using this prefix kilo this semester, and we'll also be using the prefix milli. These are both metric prefixes, like millimeter. Like here's a meter stick right here. There's a meter. That's our unit of length. There are 1,000 millimeters, those smallest divisions on the stick. There are 1,000 of those. So each one of those is 1/1000th of a meter. Each of them is a millimeter. Okay, milli means 1/1000th. Same as 10 to the negative third. Okay. So the clip and save here, alert students, is that these are our units. Right there. That's not a very bright pen. It's rather disappointing, actually. Let's try the green and see if it looks any better. Ah, yes, much better. So these are our units for the semester. Okay. And the last thing I want to say in this in this video here, looking at you here through the little hole in the table, is that other units that we deal with are going to be made up of combinations of these units. So a unit of speed, you know, we think of in the English system miles per hour. For us, it's going to be meters per second. Okay. So the unit of speed meters per second is not any one of these, but it is a combination of two of them, meters divided by seconds. Okay. We're going to talk about a thing called force. The units of force are going to be kilograms times meters over seconds squared. Now, don't worry about what that means, physically what that means. The only point I'm trying to make is that there's a quantity called speed, which combines these basic units, these fundamental units, into a new unit, meters per second. And there's a unit of force. Force is going to be a major idea in this class. There's a unit of force, okay, and force is the unit is a combination of these basic units. This is what's called a composite unit. So these units here are known as fundamental units. The meter, the kilogram, the second. But then we build up other units out of them. So these units here are known as composite units. For speed, it's meters per second. For force, it's kilograms times meters divided by seconds squared. It combines all three of them. And by the way, this whole combination, a kilogram times a meter divided by a second squared, is known as a Newton. Okay, so we take this complicated looking unit and just call that 1 Newton. Again, the point is not for you to know what this means exactly. The point is that other quantities that come up other than, you know, length, mass, and time, things like force, things like speed, things like energy, are all going to be built out of these three basic units. That's the point I want you to remember. Okay, that's the point I want you to remember. Composite units are built out of fundamental units. Now let me check my notes, make sure there's nothing that I did not miss here. I think we're okay. Finally, one sort of philosophical note before I put the end to this particular video here is that all systems of units, and I kind of alluded to this earlier, all systems of units are arbitrary. What does that mean? That means that we can pick any system of units we want to. We could do all of our physics in the English system. We could do all of our physics in the SI system. And there are many other systems I have not brought in. We could also pick any combination from among these different systems and do all of our math in that. We could pick the foot, the kilogram in the second. We could pick the slug, the meter in the second, those three, and do all of our math that way. So units are arbitrary, but it's an issue of usefulness and practicality. And it turns out that the SI system has, over the centuries, become the one that is most intuitive, the one that's most useful, and the one that is most globally widespread. despite the fact that we are in one of the last pockets of resistance to the metric system here in the good old US of A, this system is widely used globally. So welcome to the world of physics. Next up, what's the next topic? Next topic is my favorite topic, and soon to be yours, significant figures. See you then.